Welcome back to the deep dive. This is where we take a whole stack of interesting sources, articles, notes, you name it, and really pull out the key insights for you.
That's right.
And today, we're plunging into something pretty fascinating. It's this intersection of really advanced AI and, well, a super specialized field.
Neurosurgery, no less.
Exactly. How AI is starting to, see and actually understand incredibly complex visual stuff right in the middle of an operation.
It sounds futuristic, but the concepts are becoming, well, more graspable.
So our mission today, to give you a kind of shortcut, make you feel well-informed about how AI actually interprets all this visual data, and we'll focus on a core idea called annotation.
Yeah, annotation sounds maybe a bit technical, right?
A little bit.
But it's essentially just teaching the AI, like labeling a picture, pointing things out.
Okay.
And what we want to do today is actually walk you through a practical step-by-step example. We can use tools that are surprisingly accessible, like Google Gemini.
Right, so people can actually try this themselves.
Sort of simulated, yeah. We want to show you how you can mimic a complex AI process, like how a digital neurosurgical assistant might see live video right there on your own computer.
That's amazing. That really gets to that idea of personal AI, doesn't it?
It really does. It highlights the power that's becoming available. So get ready. You're going to see how AI can start making the invisible, well, visible, giving us insights we just didn't have before.
Okay, let's unpack this then. We're talking about teaching AI to see something incredibly complex, like a neurosurgical field. Practically speaking, where do we even begin if someone listening wants to simulate this? What's the very first step?
That's a great starting point because, before AI can understand anything useful, it really needs training.
Right, training data.
Exactly. And for visual stuff like images or video, that training kicks off with annotation. Think of it like using a highlighter, drawing attention to what's important for the AI.
Highlighting the key bits.
Precisely. And what's really cool here is, while building these huge AI models often takes specialized, expensive platforms.
Yeah, stuff most people don't have access to.
Right. We can actually simulate that vital first step using everyday tools.
Yeah.
For this demo, we'll create what we call pre-annotations.
Pre-annotation?
Yeah, they're basically simplified manual labels we add to images ourselves. They simulate what a really sophisticated AI might output in real time.
Okay. So we're showing the AI what the output of another AI might look like?
Exactly. And this lets a general-purpose AI like Gemini interpret those signals. It proves the concept without needing massive, specialized data sets. And it really hammers home how crucial human input is in guiding AI.
Okay, got it. So for our listener wanting to try this simulation, how do they get started? What's step one in creating these pre-annotation?
Step one is selecting your sequence. You need a really short but impactful piece of video.
How short?
Maybe just 3 to 5 frames, consecutive frames.
Okay, 3 to 5.
And the key is choosing frames that clearly show two things. First, at least one obvious anatomical landmark, like, say, an optic nerve, maybe part of the cerebral cortex, even an aneurysm if the footage shows one.
Something identifiable.
Yes. And second, a critical event. Or maybe the moment just before one happens, like the very start of a bleed, a hemorrhage, or maybe a key moment in dissection.
Okay. Landmark and event.
And this is absolutely vital. Any video you use must be completely de-identified. You have to comply with all privacy regulations. Safety and ethics first, always.
Absolutely critical. Okay, sequence selected, then step 2.
Step 2 is extracting keyframes. You just need to pull those 3 to 5 frames out as high-resolution images.
How do you do that?
It's actually pretty easy. Standard video editing software usually does this, or honestly, there are lots of free online tools that can extract images from video.
Okay, so accessible tools again.
Yep.
But I have a question here. Why static frames? Wouldn't a real surgical AI look at the live video feed? Why break it down into still images for this demonstration?
That's a really important clarification. General AI models like the Google Gemini we're using for this demo are incredibly good with still images. So for the purpose of this simulation, which is all about showing how Gemini can interpret the visual cues you manually add using static, high-res frames works really well.
It simplifies things for the demo.
Exactly. It lets us focus on Gemini's reasoning ability when it's given specific human-guided inputs. It keeps our personal AI approach manageable while still showing the core concept of visual understanding.
Makes sense. Okay, on to step 3 then.
Step 3, manual annotation, which is just adding those visual cues yourself.
This is where you put on your AI trainer hat.
That's a perfect way to think about it. And you'll use a simple image editing tool. Seriously simple.
Like what? Photoshop.
Photoshop works. GIMP, if you use open source. Or even presentation software like PowerPoint or Google Slides, anything to let you draw shapes and add text.
Wow, okay. So what do you draw?
Right. For your anatomical landmarks, pick distinct, consistent colors. Let's say green always means optic nerve, maybe blue for the cortex, yellow for an aneurysm. You follow that rule.
Green for nerve, blue for cortex.
Yep. And you literally draw on the image. Precise bounding boxes. Those are just neat rectangles or maybe polygons to trace the shape more accurately, or even just little key points to mark specific spots.
Okay, colored shapes around the important anatomy. What about events?
For critical events, choose a different, really obvious color, like red, something that pops.
Red for danger.
Kind of, yeah. You might draw a simple circle around the area, maybe an arrow pointing to it, or even add a tiny text overlay, like hemorrhage onset.
Got it. Violate the critical moment.
And the absolute most crucial thing here, I can't stress this enough, is consistency.
Ah, the colors have to mean the same thing on every frame.
Every single frame. Green always means optic nerve in your sequence. Red always marks that event. That consistency is what helps the AI learn and understand what it's looking at. It makes your manual input actually work.
Consistency is king. Okay, and the last prep step?
Step 4, you prepare your prompt text. For each image you've annotated, you write a short, clear prompt, a question or an instruction for Gemini.
That's kind of prompt.
It basically introduces the image. This is a frame from neurosurgery, and then asks Gemini to interpret the color codes you just added within that surgical context. You're setting the stage, telling Gemini how to think about the image.
Okay, so image, annotation, context, prompt. Got it.
Now we get to the really exciting part, bringing these annotated frames to life using Google Gemini.
This is where we simulate the digital assistant.
Exactly. This is where we see how it might interact with visual data, in real time in an operating room setting. It's a simulation, but a powerful one.
So how do you set this up if someone's following along?
First, just the basics. Stable internet, have your annotated frames ready to upload or show, and have Google Gemini open in your web browser.
Okay.
Then imagine you're showing this to someone. You'd share your screen, probably focusing just on the Gemini window.
Right, and you'd explain what you're doing.
Yeah, you'd start by saying something like, look, real surgical AI needs massive data sets, specialized tools, but what I've done here is pre-annotate these frames.
To show how a general AI, like Gemini, can understand complex visual cues if you give it the right context.
Exactly that. It's a way to demonstrate that potential for real-time support, even with this kind of personal AI setup.
This is where it gets really cool, I think, showing how even a readily available AI, guided by that human expertise, can start to interpret these really sophisticated medical images.
It really is. Okay, let's walk through it. Imagine frame 1, anatomical landmark recognition.
Okay, so I'd upload or show my first annotated frame, the one with the green box around the optic nerve, for example. What's the prompt?
Your prompt to Gemini might be something like, Gemini, I'm showing you a frame from a neurosurgical operation. The green bounding box highlights a specific anatomical structure. Based on the context of neurosurgery, what do you infer this green box is identifying, and why is it important for a surgeon?
Asking it to identify and explain the significance.
Precisely. And Gemini should process the image and your prompt. What's really striking isn't just if it identifies the optic nerve, but its ability to potentially infer why it's critical based on the context you provided.
So it's not just pattern matching the green box?
It's moving towards contextual reasoning, which is vital in surgery, right? Knowing why something matters. If that green box is the optic nerve, well, damaging it means vision loss. It's critical.
And a real AI assistant could then?
In a real scenario, it could flash an alert if instruments get too close.
Warning.
Approaching optic nerve. That's a huge safety layer provided in real time.
Wow. Okay, that's powerful. Now, frame 2, the critical event onset.
Right. So you display your second frame, the one with, say, the red circle marking the start of a hemorrhage.
And the prompt for this one.
Something like. Now, observe this next frame. The red circle indicates a critical event that has just begun. What kind of event might this be in a neurosurgical context? And what immediate action might a digital assistant suggest? Gemini sees the anomaly, reads your prompt providing surgical context, and should link the red circle to a critical event, maybe suggesting hemorrhage. What's amazing here is how a general AI connects a simple red circle to something so serious.
It's the context from the prompt that enables that leap.
Absolutely. It highlights the power of good prompt engineering. This moment, hemorrhage onset, is incredibly high risk.
Yeah.
A fully trained digital assistant could instantly alert the surgeon, maybe even start quantifying blood loss or suggest the right tools for hemostasis, stopping the bleeding. That could dramatically improve safety and outcomes.
Okay, so frame 1 is recognition and significance. Frame 2 is event detection and immediate action. What about frame 3?
Frame 3, temporal progression and workflow analysis. You show your third frame, maybe the hemorrhage is progressing, or perhaps the surgeon is now actively managing it.
So it shows change over time.
Exactly. And your prompt might be, looking at this sequence, how does the AI's ability to track these events over time contribute to understanding the overall surgical workflow?
Looking at the bigger picture now.
Right. Gemini would hopefully discuss the time element, the workflow, because by tracking things frame by frame, the AI starts to understand the narrative of the surgery, the temporal context.
It can see phases, like moving from dissection to controlling bleeding.
Precisely. It allows for surgical phase recognition, identifying steps. Okay, we've transitioned from dissection to hemostasis. An AI could build a kind of surgical roadmap as the operation proceeds.
And even predict things.
Potentially, yeah. Predict remaining duration, maybe flag deviations from a standard workflow. This isn't just about efficiency. It's an incredible tool for analysis and even for training future surgeons. It captures the story of the surgery.
That's quite a journey from symbol-colored boxes to understanding the surgical narrative. So let's pull this together. What does this all really mean for you, the listener?
Well, I think what we've just walked through is a really potent glimpse of how AI, even more accessible AI like Gemini, can look at complex visuals and actually reason about them. It finds meaning.
And provides insights that could be genuinely useful.
Definitely. And the absolute core takeaway here has to be the importance of annotation.
Those manual colored boxes we talked about?
Exactly. That process, that human guidance, that's precisely how sophisticated AI models learn in the real world, just on a much larger scale. It underscores that you absolutely need expert human input to build AI that's reliable, safe, and actually relevant in a clinical setting.
Human expertise is indispensable.
Completely.
And this demo, even as a simulation, it really highlights the real-time potential, doesn't it? A digital assistant offering guidance, safety alerts, right when they're needed most.
It paints a clear picture of that potential partnership. Human skill augmented by AI awareness.
Yeah. And finally, I think it really showcases the impact of personal AI. The fact that these quite advanced capabilities are getting easier to access means you can do powerful demos, you can start exploring these ideas even without needing giant, dedicated annotation platforms.
It democratizes the exploration phase in a way. You can start playing with these concepts.
Which brings us back to the human expert. Your deep knowledge in whatever your field is. That's what's truly invaluable for guiding and checking these AI systems. It really is a partnership.
Absolutely. It's not AI replacing experts. It's experts leveraging AI.
So today, we really peeled back some layers on how AI is learning to see. And we saw just how vital that human input, that smart annotation, really is.
Yeah, it's not just about fancy algorithms, is it? It's about thoughtful guidance.
Smart annotation.
And maybe connecting this to the bigger picture. It raises a question for you, the listener, to think about.
Okay.
As these AI capabilities like visual understanding become more accessible, what other complex visual fields, completely outside of surgery, could benefit from this kind of personal AI approach? Where else could human expertise, combined with a bit of manual annotation, unlock some really groundbreaking insights from visual data?
That's a great question. Where else could this simulation approach spark innovation? Something to ponder. Well, that's it for this deep dive. We hope you feel a bit more informed, maybe inspired by the potential here, and also by your own ability to potentially engage with and shape this technology.
Thanks for joining us.
Until next time.